Alrighty, and last but certainly not least, we have Shaun, and he's going to be talking about objective assessments of concussions using brain vital signs.
Good evening. My name is Shaun, and I am a former competitive rugby player. A few years ago, I suffered a really bad concussion and ended up spending the night in hospital, and the next morning I had an appointment with a neurologist. And I said, "Doc, how bad is it?" And the doctor said, "Well, we don't really know for sure." So I said, "Okay, well, when will I get better?" And again, same response. "Well, we don't really know for sure." And this highlights the problem, is that the current standard of care for concussion is almost entirely subjective. So doctors can't actually provide accurate evidence-based treatment. So to address this, my lab has created a concept called brain vital signs, which is fundamentally a portable numeric assessment of brain function, which we can do in just less than 5 minutes. So think of something like a blood pressure cuff or heart rate monitor, but for your brain. You see, the brain is, at its very base, a pattern recognition machine. If you provide it a set of stimuli, it responds with a very characteristic output. For example, if I say the words bread butter to you, your brain goes, "Okay, I understand the relationship between those words." But if I go bread bicycle, the whole brain goes "Wait, no, what? What is that?" But the concussed brain doesn't process this information in the same way, and that effect is measurable. So then, and for the sake of time, let's just call them implementing fancy algorithms, we can then translate these complex brainwaves into simple clinical brain vital signs that are on a scale of 0 to 100. And these make it really useful to track changes in brain function over time. So for my thesis, I looked at 6 different brain vital signs in a group of ice hockey players. At the start of each season, every player received a baseline scan. And then over the course of the season, if they sustained a concussion, of which we had 12, they were scanned 2 more times. Firstly, straight off the rink at the side of the ice, and then much later once they had completed their clinical concussion protocols. Now my results are displayed in the bottom row of the slide here, where each figure kind of contains all 6 brain vital signs arranged to present a sort of visual profile of each time point. And we found that concussions result in significant changes in all 6 brain vital signs, to the point at which it creates a completely separate profile relative to baseline. Now, while there was some degree of recovery towards return to play, we did notice sustained significant changes in a measure of basic attention, which suggests that these players are being cleared to return to the ice while still showing signs of impairment. Now, not only does this put them at risk for potentially far more severe consequences, it really highlights the lack of sensitivity of current concussion protocols. So ultimately, what we're trying to use these insights for is to develop a numeric assessment of severity of concussion, as well as to more closely monitor the entire progression post-injury through to recovery, so that we can say for sure what the state of your brain is. Thank you. Yes?
What would you say the average current return to play timeline is?
Not good enough. In my data set, it was around 10 to 14 days, but some players are returning in as much as 3 to 5. And that's kind of stressful because the actual NHL concussion protocols, it has 7 steps, and you can only graduate 1 step per day. So you start getting a little wary of that. So what really the current standard of research is suggesting that clinicians kind of overcompensate and just tack on an extra week at the very least. Yeah.
So your research is pointing out that there's a really big risk of just complete undertreatment and huge violation of all these health systems. Do you think you'll face much of a barrier with adoption in industries like sports industry?
It's an excellent, really topical question as well. I don't expect so, simply because, all the attention that concussion's getting right now, the leagues really have to adopt the best available policies in order to prevent these injuries and to prevent them from reoccurring, and to make sure that when players have concussions, that they make sure they're treated fully before they return. Because sport, it's different to real life. If you're in an accident or if you fall off a playground and have a concussion, athletes, the moment they're injured, their number 1 priority is to get back on the ice. So you have to be able to objectively say when that can happen, and not let any subjective kind of interference play in that role. Oh, lots of questions. Sorry, I think you had your hand up first. Yeah.
Do you have anybody with multiple concussions over your data sets?
Yeah, we did.
Build-up effect or different effects?
Yeah, I had 1 player that had 3 consecutive concussions. 1 concussion, 2 weeks later, another concussion, 3 weeks later, another concussion. So this player passed the concussion protocols both times. I don't obviously have the data with me right now on the slide, but the case study is really, it's pretty graphic. You can see very, very, very clearly, and even on a statistical level, it's rather crazy. That player actually ended up retiring after the season. Yeah, over there.
Is the reason that they're allowed to return to play, is it part of that like patients are recognizing what concussion symptoms are, or is it that they're eager to get back to play?
It's a combination of all of the above, really. So clinicians don't actually have tools that are sensitive enough to really delineate what is injury and what isn't. So a lot of the treatment is based on subjective symptom assessment. So how are you feeling today? But I mean, how can you put a number on a headache, or how can you put a number on blurred vision, or attention is such a vague measurement that subjectively you can't define. But using, brain imaging, or, what we use as EEG, you can really, really isolate those components. Yes, sir?
Just wondering to what extent this technique can be used with kids, so teenagers obviously.
Yeah, so this data set was with junior A team, so that's age 17 to 21. I've currently got a 2-year study going on with bantam age groups in both hockey and football, so that's age 11 to 14, so that data should be coming out pretty soon. But we expect, from a electrophysiology perspective, the kind of stimuli that we use really translates well from all age groups, so we expect to see very similar results. Yes.
This question's a bit more on the technical side. What exactly are the brainwaves that you're measuring? And you said that you're using an ECG to detect them?
EEG. Yeah, so it's electroencephalography. It's electrodes that read the electrical signals from your brain as the neurons activate and process the stimuli. You basically read what we call event-related potentials. So the stimuli, every stimulus creates an event-related potential, and by using multiple repetitive stimuli, you can average that, and that kind of cuts out your signal to noise, and it gives you very characteristic brain responses. Yeah.
Do you worry about them trying to fail the baseline test?
That is an excellent question. The whole processing of the stimulus is offline.
Okay.
So it's really very difficult to have a false negative in that sense, to tank a test, I think is what the players try and do on some of the more like paper-based tests. So when you do this EEG, you actually can develop like a compliance measurement. So you can actually see if someone complied with it, because you can tell how much attention they were paying during the scan. So that's something we're working on as well, because it is a concern, obviously. Yeah.
I've heard them doing that in the NHL where they try
Oh, of course, yeah. And then
to get back.
when you get a concussion, you go, oh, well, it's the same. So yeah.
Yeah, when people fail under non-concussion conditions or following up on that, like if you're exceedingly tired when you take the test.
Yeah, that's a great question. So there is a lot of individual. Yeah, there is a lot of individual variance. This is why we use kind of multi-parameters. So we get to look at, in this case, we look at 6 different features. So we're trying to develop different profiles, so we can have a concussion profile, we can have a sleep deprivation profile, and then we can basically use classification to figure out what's really going on. But it's still at a very early stage, but yeah, that's something we're working on. All right, well, I invite everyone to ask me questions afterwards.
Thank you so much.
Yeah.